But yeah, okay, let's start again then. I'm Fiona. I'm a software engineer at Grafana Labs, and yeah, I'm going to be talking about OTEL Delta temporality support in Prometheus um, today. So let's first define temporality. So this is how additive data types like counters are expressed in time, whether values incorporate previous measurements or not. So just as a bit of an aside, when I say counter here, I mean something that records something like the number of requests. So Prometheus calls this a counter, and OpenTelemetry calls like the closest equivalent a sum. But I'm just going to be using counter to refer to both Prometheus counters and OTEL sums from the rest of the talk. So in the OTEL world, a sample has two timestamps. It's got a mandatory timestamp, which is of when the measurement was taken, just the time unit nano, and I'm just going to be calling that the reported time from now on. And it also has an optional start timestamp, which indicates when the measurement started. So we're just going to call that, start time. And cumulative temporality, hopefully we all know this, we all love this, right? Because this is what Prometheus supports today. So in cumulative mode, this means each reported value is the running total since we started measuring, and all the previous values are incorporated too. And with the OTEL start times, this means successive samples share the same start time until there's a reset. Like you can see how in this example, all four samples share the same start time t0. And then you see at time t1 the value is 1, at t2 it's 5, which means between t1 and t2 we've added 4 samples. No, sorry, not 4 samples, account 4. And in graph form, the samples will look something like this if you draw them by their reported time. In the case of counters, you usually want to see how much the count has increased in a time range and maybe get a per second rate. So with cumulative ones, you find the increase by taking the diff between the start and end values in the range. But one thing to take into account is that cumulative counters might not just keep going up and up forever. So we might start taking measurement when the application starts, right? But then it restarts and we lose all the data, the in-memory data. So at this point, a cumulative counter would reset and it will start from 0 again. So if you want to work out the sum now, you can't just subtract the first sample from the last value. You've got to sort of detect the resets and treat the range as multiple segments, get the diff for each segment, and then add them up to get the total value. So if you've got OTEL start time, it's fairly easy to detect when a reset has happened if the start time for the current sample is greater than or equal to the reported time of the previous sample. Prometheus counters, by definition, are cumulative. So, and they also have to be monotonic. So the counter should only decrease in value if a counter reset happens. Each sample only has a single timestamp, the time at which the value was reported. There is also the created timestamp concept that's been mentioned a bit before in a few talks, but it's not stored as part of each sample. So to detect resets, we can't use the start time for now. Instead, Prometheus counter functions like increase and rate detect resets by checking if the previous sample is lower than the current sample. So this isn't foolproof. We can miss resets if the counter increases really, really fast after starting. But yeah, so yeah, the process we just described with all the pretty graphs and stuff, that's basically how Prometheus does the increase calculation. Though the increase function also does some extrapolation. So unfortunately, the first and last timestamps in a selected range might not match with the boundaries of the time range we're querying for, and this is fairly frequent, I guess. How Prometheus deals with this is that it extrapolates to guess what the values at the boundaries are. So we want to do this because otherwise, if we just take the diff from the first and last value, it will be an underestimation of the actual increase. Yeah, so, and then when you're looking at the diffs itself and at the extrapolated points, you take them into account and you then do the summing and stuff. Cool, so finally actually onto your delta temporality in some respects. So with delta temporality, the reported value for a sample is the change since the previous reported value. so it's supported by OTEL, but not really by Prometheus. In the OTEL case, this means that successive samples wouldn't have the same start time. Start times are exclusive by definition in OTEL. So in this example, for example, you can see that the samples don't have overlapping intervals. So finding the increase of a delta counter over range is different to cumulative counters, since all the sample values are independent. Each sample here with a delta sample just contains the increase within the interval. So one way to find the increase is you just sum up all the samples in the range, which is fine. There is a consideration though, that is the result might not specifically be for the selected range. So like I said, each delta value tends to be collected over interval. I drew some, I don't know, reddish, purplish lines to try and show the interval for which each sample was collected, and you can see how the interval for the first sample is not completely within the range. So in this case, it means that the actual increase that you're returning isn't quite what you requested. Whether this is good or bad, it depends. It depends on what you want the increase to mean. There are also methods to sort of like extrapolate or interpolate to just get the proportions of the samples within the range you want. So yeah, now onto the, I guess, the OTEL compatibility side of things. So Prometheus does have that ingest endpoint for OTEL metrics, but initially and by default it rejects deltas. And there are downsides to using delta temporality, but there are also use cases like batch jobs, serverless, and of course the just being able to ingest stuff from support more things from OTEL. So for this, it would be good to be able to support deltas in some form in Prometheus. So the first iteration of OTEL delta support in Prometheus was to convert delta metrics to cumulative on ingest. So the converted cumulative version is stored. The conversion is just done by keeping a running total. So when a new delta sample arrives, it's added to the total and then the resulting value is forwarded. There are a few problems with this though. One is it lacks out of order support. So the conversion process requires adding the current sample to the sum of all the older delta samples. So deltas that arrive out of order can't be added without rewriting new samples that were already ingested. So in practice, this means we have to reject samples that arrive out of order. Another problem is that the shape of delta data tends to differ from cumulative data. So while delta can be emitted at regular points, in some case, like with the OTEL SDKs, we only emit these points when there is a change in the collection interval. In this example, since the counter wasn't incremented between T2 to T4, those samples are missed, and it leads to very irregular gaps between delta samples. And this means the converted cumulative data can interact awkwardly with Prometheus counter functions. So for Prometheus, if you want to calculate how much a counter has increased, it needs to diff the first and last samples in the range. So this requires at least 2 samples for a result. If your OTEL delta counter only updates occasionally, you might get an empty result when the counter has increased, but only once in the selected range. This is an issue also that affects cumulative counters in some ways. And the other issue is that Prometheus does the edge extrapolation to cover the entire range, but it also tries to avoid overestimating when it thinks the series has started or ended within the window, and it tries to guess this based on the typical sample interval. Delta converted series can be irregular, so the intervals might not be a good way to estimate the start and end of a series. So given these problems, it would be nice to avoid doing the conversion. And like, I do have to say, I did lie a bit earlier, or at least I wasn't quite precise. So if we flash back to, I don't know, 5 or so minutes ago, I said Prometheus doesn't support delta temporality. What I meant then was support is like in the context of scraping and querying semantics. So the standards metrics pulling scraping path is cumulative only. We can't scrape deltas-ish. And Prometheus counter functions like increase and rate are designed for cumulative counters. But it's always supported just storing any old values, so like delta values. The storage itself is type agnostic, So if you push deltas into Prometheus with like remote write, it will happily just store it, and then these can be read back. So to support deltas ingested via the OTLP endpoint in Prometheus, we've done a pretty simple thing of allowing them to be ingested natively under a feature flag. So this means instead of being rejected or converted into cumulative value, the delta sample will be written as is. So this is the current state of delta support, and it gets around the out of order problems we have with doing the conversion, and it does help with the querying problem, but that's not perfect. So for the rest of the talk, I'm just going to walk through some of the current issues with the querying and ideas to improve that. So I said it's queryable, but there are caveats. So if you just query for the metric itself, you get the raw delta values. That's nice, that's fine. But what if you want to get the increase over like a selected range? So like we said before, Prometheus's increase function is designed for getting the increase in the range for cumulative metrics. If you try and query for a delta metrics with increase, okay, Prometheus will run a function on it, but what it'll try to do is it'll try to take first sample away from last sample value and adjust for resets in a way that doesn't make sense for deltas. So to actually get the increase over the range for native delta samples, you have to add up all the values in the range. And you can do this. There's a sum over time function in Prometheus. Note that this just adds up all the samples. It doesn't do any extrapolation or interpolation to adjust for any ranges. This does mean that different functions are needed for delta and cumulative metrics. And yeah, whether this is a problem or not is, sometimes it might be better to have something that is clearer that these are separate types. But yeah, the problem here is also there's no set way of distinguishing whether a metric is delta or cumulative at query time. To use the correct function, you need to know how a metric is collected, but even that's not foolproof. So when you're ingesting, say via OTEL, the temporality can change in your ingestion pipeline with things like the delta to cumulative process to confuse things. So one option we considered to alleviate the query problem was enforcing some sort of typing. Prometheus does have defined metric types like counters, gauges, and so on. And when you instrument an application, you need to define a type, and that is exposed at scope time. And there are suffixes like total or sum added for counters by convention, but they're not strictly necessary, especially with OTEL metrics, which have the convention of not adding type suffixes. And also, like, the typing isn't persisted properly as its own sort of like field, and type information isn't really used at query time. This has changed a bit for native histograms, but in general, it's not really. This is like the current state anyway, but there is a newly introduced Prometheus proposal that adds type information as metadata labels to series. So for example, a counter series, it would add a type equals counter label. So for deltas, we thought about piggybacking off that. So we could have metadata labels to distinguish between deltas and cumulative metrics. There are a few ways to do this. For example, adding a new temporality label with the values cumulative delta. So users then could then see the temporality metric and then choose the right function. And we could also have the query engine check the label and add warnings if needed. But this still requires, like I said, different functions. Separate functions do keep things simple, and it allows us to, adjust each function independently based on the different characteristics of each temporality. But this can also be a bit of a operational headache. For example, if you're migrating from one temporality to another, you're going to need to update all your dashboards, alerts, recording rules, and so on. Or if you're ingesting the same data, different teams or users, but different temporalities, you still need to maintain two versions of the same query. So one way around this is to introduce function overloading. So that by having temporality metadata as labels on the series. So we could extend increase to work transparently with both delta and cumulative metrics. So the engine could check the temporality label, and if the series is cumulative, then do what it does today. If it's delta, then take the delta path and do sum over time. With everything, there are trade-offs though. That does add engine complexity, and the same query could return different results depending on temporality, even if it's the same source being measured, because the cumulative path would do edge extrapolation, while the delta path would just sum everything in the range. We could try and mimic the cumulative extrapolation logic for deltas, but this might not be desirable for delta users, and the sparseness of deltas can make extrapolation less reliable anyway. It also creates inconsistencies between functions. So for deltas, if we do this, then both increase and sum over time will work for deltas, but then if you try a sum over time over cumulative, then that would just not give you the right result. Okay, and then we could then overload sum over time and make it work for cumulatives like increase does, but would that be more surprising or helpful? And then it goes on and on. There might be more functions, and we had to decide, do we want to also have this dual path and overloading? And it just adds a bunch of complexity. So for now, we've decided against this overloading. So the query engine has historically been like type agnostic. The same expression over the same samples gives the same result, regardless of any labels. So we want to avoid disrupting that for now, especially since persisting types on series as labels is still new and experimental. It's not something, I guess, to discuss forever. Maybe like in future major releases, if we get stricter typing and stuff, we could revisit overloading. But for now, it's something where we'll see how far we can get without it. So far, we have been treating delta and cumulative metrics as sort of distinct types, but really delta metrics are basically cumulative metrics, even without the conversion process we talked about earlier. So regular cumulative metrics give you many samples of a running total, and then they occasionally reset. But you can think of deltas as a special case of cumulative that resets after every sample. So the graph on the right tries to demonstrate this, like each of the blue dot is a delta sample point. The value accumulates till the blue dot and then resets to 0 and repeats for the next step. But we have said we can't use increase on native delta samples. This is because Prometheus counter functions identify resets using drops between consecutive sample values. But for delta, that's not a very good indicator. For example, 0.2 on the slide is greater than 0.1. We know, since these are delta values, that between 0.1 and 2 there is a reset, but there's nothing in the data for Prometheus to figure that out. So here's where OTEL's notion of a start time for a sample becomes useful. As a reminder, OTEL sample has two start times, with the start time indicating when a measurement started, or another way to look at this is where the reset happens. So when ingesting OTEL samples into Prometheus, for now, synthetic zeros can actually now be injected for OTEL timestamps. So essentially, one OTEL sample will turn into two samples for the same series in Prometheus, a 0 value at the start time and an actual value at the actual time. So with that, Increase would be able to identify resets properly for deltas, as there's always going to be a drop between each actual sample values, and then you could basically use the same functions for delta and cumulative counters without any label-based function overloading. But if you have delta samples in consecutive intervals, then the start time of the current sample would be set to the reported time of the previous sample, and we can't have two samples at the same timestamp for a single series. So an evolution of the 0 sample ejection is storing timestamp, or created timestamp as it's currently known in Prometheus, per sample alongside a pre-existing reported timestamp, and that can then be used in queries. The tighter coupling between the start time and the reported time means that increased calculations can be made better. So the stored start time can be used to detect resets instead of just guessing, and the estimation for the sample interval for extrapolation can be improved. And yeah, the resets can't be lost as they could be in the 0 injection case. Additionally, this isn't just useful for deltas, cumulative counters also get more reliable, and this can also help make native histogram reset detection more efficient. Additionally, it could also possibly allow Increase to handle non-monotonic counters, which are also a thing in OTEL. So there are questions on introducing this, though, because there's the impact of basically adding this additional field to each sample on performance, and it requires some benchmarking and testing in real world situations. But it seems like a promising approach, and the one we're pursuing for deltas for now. So whatever we do, I do think that accepting deltas will always add some sort of level of like friction and complexity, especially if you're trying to store metrics of both temporality. Created timestamp per sample doesn't solve everything for deltas. There are edge cases like missing start times and considerations on whether extrapolation should be the default for deltas or not. And also, it could also affect how downsampling works because you start missing data if you miss delta samples. But it's probably the best balance between OTEL compatibility and adding complexity to Prometheus, at least in the short term. So we've basically got to end talk now, and just to sum up everything that I've said. So today you can ingest OTEL deltas as is with Prometheus if you enable a feature flag. To aggregate them, you'll have to use sum over time and divide by the range to get the rate. But remember the caveats on the whole querying process. And if you ingesting a mix of both delta and cumulative values, you need your own convention for being able to distinguish them. There are a few new and upcoming features in Prometheus that will also help with improved delta support. So in particular, implementing the created timestamp per sample. So that will allow delta counters to be treated just like any old Prometheus counters and have functions like increase just work without needing any special metadata labels for the engine to read. But adding labels might still be useful in an information sense. It might be useful for debugging or also round tripping data back into OTEL when needed, even if it's not a strong dependency on the query path. So yeah, just to wrap up, want to give a big thanks to everyone who's contributed to the discussions and PR so far. I've linked the Delta proposal if you're interested in learning more. And if you're interested in contributing, there is a Delta support working group that meets up every couple of weeks. That's in the Prometheus calendar. And yeah, of course, thanks everyone for listening as well. And any questions?
Thank you. And I would say, Björn, already get wired up if you want to.
Hello. So you mentioned that the start time optional.
Yeah.
But what's the plan when the start time is?
Give up? No. So
Hello.
like the idea, I guess, that I'm kind of floating around is to set like if the start time is optional, set the start time to the basically the reported time as well, which you could do if we had created timestamp per sample. So the idea is that it's like, oh, if you don't have start time, it must mean that the data reporting is for this infinitely small interval of just now, and that should, when you put that in something like rate, essentially what it would do is do a sum over time. Yeah, possibly with some adjustments. That's the sort of general idea anyway.
All right. Any others? Questions? Yeah, there's one.
Hello. Thank you for the talk. I'm just curious. I haven't followed this whole delta versus cumulative work that has been going on. Thank you for the for the summary. I was curious about what's the advantage of storing deltas versus converting from delta to cumulative at ingest time.
So what's the advantages?
Of storing delta directly instead of just converting it.
So I guess if you convert them at ingest time, the big problem is you can't support out of order data because when you convert, you depend on all the old data. So when you have the new data, then that's not there. There's also some like I guess possible usability concerns because you write data and it's not quite the same as the data you write, and that can be confusing. Yeah.
Any others? One more? Okay, one last one.
Thank you for the talk. When you mentioned the approach for the increments, basically, like in Victoria metrics, there are now 3 implementation of increments, if I remember correctly, and the fourth one is the Prometheus, or like that's implemented in Victoria as well, and like neither of them is doing the interpolation. So like basically, what you are suggesting is to make the fourth option to make the increments, and in my opinion, when you would do that for every query, it would simply cost too much on CPU. Like maybe for the end users, is good to make them decide if they want to use.
Da-da-da.
So in the end, what they did in Victoria Metrics is that there is increase pure, increase Prometheus, and the user is the one who is deciding what should be the algorithm. So, like, isn't that better to like decide based on the use case? Because most of the time, I just want some data, and I don't care if the metrics difference is done from the first in the interval and last in the interval, or the one before and one after, or something different.
Yeah, so I guess so basically giving the power to users to decide how they want to have these increase calculations work essentially is the suggestion. Yeah, so I guess there's always a balance between like doing something magical and it just works, but then there's always edge cases and things that don't. So actually, Prometheus has done something similar to Victoria, like has started investigating something similar to Victoria metrics in terms of the rate and increase calculations. In terms of so there's a couple of additional modifiers on the feature flag for doing different ways of extrapolating or interpolating with cumulative metrics with modifiers. So I guess the idea there is actually if those modifiers, they're tested and they work, then we'll probably follow a similar path of like here's how increase works by default. But there's also these other modifiers you can add to make it do something slightly different, like a sum over time, or more something more like that, or do something more interpolating and looking at samples outside the time range. So yes, I think it's sort of like we are sort of following that path actually. With Prometheus and with deltas that does that can help too if we do the created timestamp stuff.
All right, thank you again. And